In this video, let's practice applying our understanding of linear systems of equations to solve these mixture percent concentration problems together. And just to kind of help make each of these problems a little bit easier to understand, I'm actually going to make a table for each one of them to help organize our information. Alright, let's get started. In this first example, it says how many gallons of 3% acid solution must be mixed with 60 gallons of 10% acid solution to obtain an acid solution that is 8%. So if you're trying to understand what's happening in this problem, just think about maybe there's two big containers. One container has this solution that is 3% acid solution, and there's another big container here that has 10% acid solution. And we're going to be mixing those two together, but we have to find out how much of each one to put in so that we end up with an 8% solution, right? So it's going to be somewhere in the middle. Now we know how much we're putting in of the 10% solution. We're being asked to see how much of the 3% solution we should be putting in. Now the 8% is closer to the 10% than it is to the 3%, so I think we're going to need more of the 10% solution than the 3% solution. To start, I'm going to go ahead and make a table, so feel free to pause to sketch this out. Basically, we have three rows here. The first row is for the first solution, the second row is for the second solution, and the third row is for when you mix them together. And then we have basically three columns here. So this is the amount of gallons that we're going to have of each one. This is going to be what percent of it is made up of that acid solution. And then we have this third one, which is going to be what concentration it is altogether. Now I'm going to call this solution 1 our 3% solution, and I'm going to call solution 2 our 10% solution, right? So we know we're going to be putting in 60 gallons of this second one, that's 10%. 10% as a decimal is 0.1. So how much of that 60 gallons is actually that acid part? That's going to be 10% of 60, or 0.1 multiplied by 60. Now for solution 1, we don't know how many gallons that it's going to be. That's actually what we're solving for. So I'm going to introduce a variable here of x, and that's going to be how much of solution 1 we're putting in. We do know, however, that the percent of concentration it's going to be is going to be 3% of that acid solution. So to figure out how much of that is going to be in that solvent there, it's going to be 0.03 multiplied by however many gallons that's going to be. All right, on to the third row. If we're going to be adding x gallons plus 60 gallons, then the total amount of the solution here is going to be x plus 60. All right, we don't know the total yet. Now the goal for this mixture is to be an 8% concentration, so that's going to be 0.08. And for this last box here, I'm going to go ahead and put the variable y. This will go ahead and represent our total solvent when it's mixed together. So we know for solution 1, we can multiply the percentage by the amount of gallons to get how much is that solvent. For solution 2, we can take this 0.1 or 10% of 60 gallons, and that's going to be the amount that's in solution 2. So that must mean that if we go ahead and multiply this 8% by the amount that is in the total mixture, that's going to be how much is in this final solvent here. So we can go ahead and say that y is equal to, just setting up an equation, is going to be 8%, so 0.08. of that total mixture, which is x plus 60. On top of that, we should also be able to say that if we add the amount of solvent in the first solution to the amount of solvent in the second solution, that'll equal the total amount of solvent in the mixture. So we can set up another equation here and say that y is going to be equal to 0.03x, which is going to be representing the amount of solvent in the first one, plus the 0.1 or 10% of that 60 gallons, that's the amount of solvent in the second solution. And so we can write this equation as well. All right, so now that we have a system of linear equations, I think we're going to use substitution here, since we can see here that y is actually equal to both of these expressions, so we can set them equal to each other. So let's go ahead and write 0.08 of this x plus 60, that's a total mixture, is equal to the total of that solvent here, which is going to be 0.03x plus 0.1 of that 60. Now this 0.1 of 60 is just 10% of 60, so I'm actually just going to go ahead and erase that and say 10% of 60 is going to be 6, so I'm going to replace that with a 6 right now. And then we could go ahead and solve this equation the way it is, or we can go ahead and multiply the entire equation left and right by 100 to clear all the decimals. So if we multiply the left side by 100, we just have to multiply this 0.08 by 100 since it's going to distribute to everything inside there anyway. So if we go ahead and multiply 100 by 0.08, we're going to be left with 8. We're still going to have to distribute that in a moment to this x plus 60. And then on the right side of the equation, if we multiply 100 by this 0.03x, that's just going to equal 3x. And then 100 multiplied by 6, that's going to be plus 600. Next, we can go ahead and distribute this 8 to both of these terms inside here. If we do that, we're going to left with 8x plus 480, and that's going to be equal to 3x plus 600. Next, we can subtract 3x from both sides of the equation here, and that's going to end up being just 5x on the left side. And I'm going to go ahead and take away 480 from both sides. And if we do that, we're going to end up with 120 on the right side. And then finally, we can divide both sides by 5 and say that x is going to equal 24. All right, so what was that original question? We were being asked how many gallons of that 3% acid solution that we needed. Remember, this x right here was representing that, so this is going to be the amount of gallons we need of that 3% solution. So when we found out that x is equal to 24, that means we need 24 gallons of this 3% acid solution. Hopefully this does make sense, because 24 gallons of this 3% solution is definitely a lot less than this 60 gallons of the 10% solution. Now remember, 8% is only 2% away from this 10%, but it's 5% away from the 3%. So to get this 8% mixture, we definitely need more of the 10% solution. And if you wanted to know the total amount of liquid in this mixture, you just go ahead and take that 24 substituted here. So 24 plus 60, there would be 84 total gallons of this 8% mixture. On top of that, if you wanted to find out how much of that first solution is that solvent, you could go ahead and take this 3% and multiply it by that 24 gallons, which is right over here, and you'll find out the total amount of that solvent that's in that first solution. And if you wanted to go ahead and solve for this y value, then you can go ahead and find out how much of the total mixture is that solvent as well. All right, let's try another example together. In this example, we have how many gallons of each of a 4% and an 11% salt solution should be mixed to obtain 35 gallons of a 7% salt solution. All right, so this one is going to be slightly different, but why don't you go ahead and pause the video and see if you can set up a table. All right, so here's the same table that we used earlier. I'm going to go ahead and label that solution 1 is going to be this 4% mixture of this salt solution, and solution 2 is going to be 11%. So solution 2 definitely has more salt in it, and we're hoping to mix this all together to get a 7% salt solution. Now, just so you kind of understand the bigger picture here, this 7% is only 3% away from the 4%, but it's also 4% away from 11%. So which one is it closer to? Well, it's closer to solution 1, so we're going to definitely need more of solution 1 than solution 2. All right, so what other information do we know? Well, we do know that we're trying to get a total of 35 gallons. That's going to be altogether mixed, but we don't know how much of each that we need. So we don't know how much of solution 1, I'm going to use x, and we don't know how much of solution 2, so I'm going to go ahead and put a y. Now we also know in the problem that this is going to be a 0.04% for solution 1, 0.11 for solution 2, and then 0.07. So just writing these all as decimals. All right, so what about the solvents here? So how much of each of these solutions is actually made up of the solvent or the salt? So it's going to be 4% of whatever this is. So we can go ahead and multiply. That's going to be 0.04 of whatever amount of that mixture we have. For the second one, we have 0.11 or 11% of whatever this is going to be. So 0.11 multiplied by y. And then finally, for this last box here, we have 7% of this 35 gallons is going to be that solvent. So it's going to be 0.07 multiplied by 35. All right, now that we have our table filled out, I think it's time to set up some linear equations. So let's see, one equation we can say is going to be, if we add up the two solutions, we get the total of 35 gallons. So if we add x plus y, that's the amount of gallons of each mixture, that should equal 35. So that's one equation. And for the second part, we should be able to write an equation about the solvent, right? So if we know that this is going to be how much is in the first one plus how much is in the second one, it should be how much is in the combined mixture. So for this equation, let's go ahead and write 0.04x plus 0.11y. And that's going to equal this 0.07 multiplied by 35. Now on the right side here, we could actually just multiply this out. So 0.07 times 35, I'm just going to replace that with 2.45. So this right here would be our system that we can solve, right? Now, if we're going to go ahead and use some different strategies, feel free to use substitution or elimination. I prefer to use elimination, so I'm going to go ahead and do that. I also like clearing the decimals, so I'm going to go ahead and multiply this whole bottom equation by 100. So that new bottom equation for the solvents is going to be 4x plus 11y is equal to 245. And then if we want to go ahead and use elimination here, then we should either get the x coefficients or y coefficients to match. I think I'm going to get the x coefficients to match because they're smaller. So I think we can make them both 4. So I'm going to multiply the whole top equation by 4. If we go ahead and do that, we're going to get 4x plus 4y. And then this 35 times 4 is going to be 140. All right, so this is going to be our system. It's going to get us the same solution, but we have nicer numbers to work with, and we can use elimination to solve. So notice how we have these matching coefficients. So 4x minus the 4x are going to cancel out to make 0 or get eliminated. Then if we go ahead and take this 4y minus the 11y, that's going to be negative 7y. And then on the other side here, we have 140 minus this 245. That's going to be 105, or negative 105 rather. Finally, let's go ahead and divide both sides by negative 7. If we do that, we're going to get y is going to be equal to 15. So if we know that y is equal to 15, that's going to be how much of solution 2 that we're going to need. We can actually go ahead and use that to find out how much of solution 1 we need by just substituting into this equation right over here. So if we know this is 15, then 35 minus that 15 will be 20. So we know from that that x is going to equal 20. So I'm going to go ahead and write x is equal to 20. And then that's going to be the amount of solution 1. So this is going to be 15, that's going to be solution 2, and this is going to be 20, and that's how much we need of solution 1. So putting this all together, we're going to need 20 gallons of the 4% solution and then 15 gallons of this 11% solution to end up with 35 gallons of a 7% solution. Hopefully it makes sense that we need a little bit more of this 4% solution, just because remember that 7% that we were looking for is closer to that 4%. So we're going to need a little bit more of that to get it closer to that percentage. All right, let's try another. If you feel like you are getting it or just want to practice, go ahead and try pausing the video and doing this next one on your own. Otherwise, let's go ahead and do it together. All right, for this example, we have the question, how much water should we add to 20 gallons of a 15% acid solution to dilute it to a concentration of 12%? Now, if you want to, feel free to pause the video and see if you can make a table on your own. All right, so now that we have a table, let's go ahead and just fill in the missing pieces that we can. So let's see what information that we have here. We have 20 gallons of a 15% solution. So I'm gonna go ahead and call that my solution 1. So we have 20 gallons, and we know this is gonna be the 15% one. I'm just gonna label that on the side. The percentage is gonna be 0.15. And let's see, we're going to be adding water to this to dilute it. So water is not going to have any acid in it at all. So that's going to be 0%, right? It's just going to be diluting a little bit, so it has less. We're trying to get from 15% to 12%. So I'm going to go ahead and write that over here. Actually, I just noticed in example 1, I didn't write that on the side. I'm just going to write it right now. That's 8% over here, but that's besides the point. I just got a little distracted there, sorry. Now, how much of this water are we going to be adding? We don't know, so I'm going to go ahead and put an X here. But we do know that that percentage is going to be 0%, so it's going to be just 0 or 0.0. And so we're going to be mixing this together. So if we mix it all together, the total expression is going to be X plus 20 if we pour those in together with each other. And we're looking for a 12% concentration at the end, so it's less concentrated than before because we're just adding water. All right, to figure out the amount of solvent for each of these, we can go ahead and just take 15% of 20. Go ahead and write that in here as 15% of 20. That's how much of this is going to be the solvent or that acid. Then we're going to take 0% of X. So 0% of X is just going to be 0. And then finally for this last box, I'm going to label that as Y. So if we knew that 15% of this 20 is going to be the amount of solvent and 0% of X is going to be the solvent in this one, which is nothing, then 12% of this total amount is going to be the solvent here. So let's go ahead and set up that equation and say that the solvent of the total mixture is going to be 12% of this entire thing, which is 12% of this X plus 20. But we also know that if we take the solvent in the first solution and add it to the solvent in the second, we should get the amount of solvent in the third solution. So we can also say that Y, which is the amount of solvent, is going to be 15% of that 20 gallons, plus I guess we could say 0% of the X gallons, but I'm just going to go ahead and write 0 here. And then we don't really need to write the 0, and then we can actually just go ahead and multiply 15% of 20, which is just going to be equal to 3. So maybe let's just go ahead and simplify this and say this is going to be Y is equal to 3. This just means that this is going to be the total amount of solvent in our mixture. All right, so what's our system? Well, we have this y is equal to 0.12 multiplied by x plus 20, right? And we also say that y is equal to 3. So this is going to be our system, and I think we're just going to use substitution to go ahead and solve this, just because we have y isolated on both of these. So we can go ahead and substitute in 3 in for y, and say that 3 is going to be equal to 0.12 multiplied by this x plus 20. And so at this point, we could distribute this 0.12 to each of these terms, but then we're going to deal with some decimals. I think what I'm going to do instead is just multiply both sides of the equation by 100 and just kind of clear out those decimals, right? So if we do that on the left side, we're going to get 300, and on the right side, we're just going to have 12, and 12 is going to distribute to this x plus 20 instead. And then we don't have to deal with fractions or decimals here, right? So if we go ahead and distribute, we're going to get 300 is going to be equal to 12x plus 240. All right, we're running out a little bit of space here, but if we go ahead and take away 240 from both sides here, then we should end up with 60, and that's going to be equal to 12x. And if we go ahead and divide both sides by 12, we can go ahead and say that x is going to be equal to 5. So what does this mean? It means that we should be adding 5 gallons of water to dilute this 20 gallons of this 15% solution. So that ends up being a total of what? 5 plus this 20 is going to be a total of 25 gallons. So if we go ahead and add 5 gallons of water to this 20 gallons of this 15% acid solution, it's going to end up being 25 gallons. 5 plus 20 is 25. 25 gallons, that's going to end up being a 12% solution. So we're just diluting it or watering it down a little bit and lowering the concentration of that acid solution. All right, let's try one more practice problem together. Again, if you're getting the hang of it, feel free to pause and try this one on your own. In example 4, we have how many gallons of each of a 7% and a 23% salt solution should be mixed to obtain 32 gallons of a 12% solution. All right, so I'm gonna go through this one a little bit quicker. Here are 3 different concentrations that we're looking for. If we're trying to end up with a 12% concentration, that's only 5% away from 7%, but it is 11% away from solution 2. So we know we're going to be adding more of solution 1 than solution 2 here to get that 12%. So just keep that in mind when we're solving this. Okay, we don't know how much of the first one we're putting in, so we're going to call that X. We don't know how much of the second one, we're going to call that Y, but we do know that we're looking for a total of 32 gallons. All right, to figure out the amount of solvent in each of these solutions, let's go ahead and multiply. This one's going to be 7% of whatever this one is. That's X gallons. Then for solution 2, we have 23% of this one. So it's going to be 0.23 multiplied by Y. And then altogether, when we mix it, it's going to be 12% of this 32 gallons. That's going to be the amount of solvent. So it's 0.12 multiplied by 32. So to set up our system, we know if we add each of these 2 solutions, they should add up to the 32 in total. So we can say X plus Y is equal to 32. And then we also know that if we add the solvent in the first plus the solvent in the second, that should equal the solvent in the third. So I'm going to say it's going to be 0.07X plus 0.23Y. And that's going to equal this 0.12 times 32, but that's the same thing as 3.84. All right, so this right here would be a system that we can solve to solve for how much of each of the solutions we need to make this. Now, just like earlier, my preference is to solve this by elimination. So I'm going to go ahead and clear the decimals for the second one and multiply everything by 100. If we do that, this bottom equation is going to be 7x plus 23y, and that's going to be equal to 384. And then for that top equation, I think I'm going to eliminate the x's just because we can multiply by a smaller number. So I'm going to multiply by 7. So we're going to get 7x plus 7y. That's going to be equal to 224. All right, so this right here can be our system. That's going to be a little bit easier to solve. Using elimination, I think we're going to subtract here, right? Just because 7 minus 7 is going to be equal to 0. So we're going to eliminate the x's. Now 7y's take away 23y's. That's going to be negative 16 of these y's. And then on the right side of the equation, we have this 224 minus the 384. So if we go ahead and subtract those, we're going to end up with negative 160. And if you divide both sides by negative 16, we're going to see y is equal to 10. All right, so that's going to be how much of solution 2 we need. We can take this 10 and substitute it in right over here, and we can solve for x, right? So if we know x plus 10 is 32, then 32 minus this 10 is going to be 22. So we can conclude that x does equal 22. So that's how much of solution 1 we need. So this 22 right here, that's going to be how much we need of solution 1. And this 10 is telling us how much we need of solution 2. So putting this all together, we need 22 gallons of the 7% solution and then 10 gallons of the 23% solution so that we can end up with 32 gallons of exactly 12% solution. Hopefully it makes a lot more sense that we do need a lot more of the 7% one as opposed to the 23% one, just because again, 12% is only 5% away from 7%, so it's pretty close. And then this 23% is much further away. So it kind of makes sense we need a lot more of the one that's closer. All right, so there you have 4 different practice problems on dealing with these percent concentration problems. There are other ways to solve these types of problems, but in this video, we focused a little bit more on just solving them using linear systems of equations. If you found the video helpful, please consider sharing with a classmate or friend and also letting me know in the comment section down below. And as always, keep up the great work that you're already doing.